guess I'm live. How you guys doing? I want to do some little math rant, but having to do with astronomy for some reason. Okay, here we go. First of all, I'm just talking at first. I'll use the board in a second. Amazing coincidences within the planets, the way they rotate around the sun. Did you know this? Let me think about this for a second. Okay, got it. All right, let's draw the first. Let's draw a circle, but make 3 of them, so they touch each other like this. And then, okay, that's 3 circles, and then you have the middle points, and then you have the outer circle like this. Okay, this is 3 circles. This is the center points. These make a triangle, if you want to do it that way. And this is a circle outside, the outside of the 3 triangles. Did you know this? If you take Mercury is the closest planet to the sun, Venus is the second closest planet to the sun, Earth is the third closest planet to the sun, but the orbit, if this is the sun in the very center, then the ratio of the orbit of Venus, which is the outer circle, to the orbit of Mercury is this circle right here, the middle circle, equal to that circle. That middle circle is Mercury. This bigger circle is Venus, and it's to 99.9% accuracy that is true. This is the orbit of Mercury. This is the orbit of Venus, and that's the ratio of those orbits. We can't explain why. It's things that are true that we can't explain are called coincidences. But who's to say that is? We may just not know why that worked out that way, or why that became that way, or why that is that way. But there's that. Now, next thing I want to do, I want to talk about Venus, the second planet from the sun. Let me think here. All right. Did you know that if this is the sun and this is Venus out here, that let's put it right on top so it'll be easier to look at that way. This is Venus, this is the sun. When Venus makes 1 year rotation, or that's 1 year for Venus, it rotates half of a whole circle. So if it starts out like that, it ends up like that. This is symbols. It makes half a rotation in 1 year for itself. That means, sorry. Oh gosh. A rotation is a day. So it makes 1/2 of a day's rotation, or 180 degrees, in 1 year for itself, in 1 year of its years. So if it makes 1/2 of a rotation for 1 year, then then half rotation is half a day for Venus. Then in a whole day, in 1 day, Venus makes 2 trips around the sun, which means that 1 day is 2 years for Venus. So each year is half a day because it's half a rotation. But 1 day is 2 years for Venus. And did you happen to know that not only that, but in 1 day, which is 2 years for Venus, so one day is equal to 2 years. And in that 1 day, the axis of rotation of Venus, so this is Venus, and this is how it rotates around this axis. This axis of rotation makes 3 complete circles. So that's funny in a way, because if 1 day is 2 years, and if in 1 day it also makes 3 rotations about its axis, then we have 1, 2, 3. written out by Venus. And why is that important and who cares? Let me show you why I think that's cool. Because first of all, 1, 2, and 3 are the only numbers in the world where 1 plus 2 equals 3. And they're all 3 consecutive numbers. You don't get that. You get one shot at that and you're done. So that's interesting about it, about 1, 2, and 3. Secondly, that's interesting, by the way, you can get something out of this one. 1 times 2 times 3, you only get one shot at that, and that's equal to 6. 3 consecutive numbers. First, why did I even say that? 1 times 2 plus 3. 6 is equal to, and the only number that's equal to the product of 3 consecutive numbers. So 1, 2, and 3, 1 times 2 times 3 is 6. You don't get that again, where 3 consecutive numbers added together. But 6 is also equal to 1 plus 2 plus 3. Yeah, that's what you don't get only one shot of. 1 times 2 times 3 is 6, but 1 plus 2 plus 3 is also 6, and they're consecutive numbers. You don't get that again. That's all. 6 is the only number that does that. 3 consecutive numbers multiplied and the same 3 consecutive numbers added give you the same number. Never. So 6 is very, very special too. Which I know, 6 is very cool for that reason, and many other reasons. But this is why 1, 2, and 3 are important too. Also, is that remember our frequency ratios for overtones. If I start with C, the next C above it is 1 octave, which is the 2 to 1. The next in the series of overtones or partials, however you look at it, is G, and G is 3 over 1, or etc. 1, 2, and 3 is C to G. This 2 over 1 is the octave, first interval in music. 3 over 2 is the second interval in music, which is the fifth, which is 3 divided by 2. So with Venus having 1 day equals 2 years equals 3 rotations, it's giving us a hint or a wink that that's the fifth and the octave ratios in music. 2 over 1 is octave, 3 over 2 is the fifth. So I think that's cool. Then another thing I think is cool. Let me think here. What is cool? Let me think. That I think is cool is fifth. Figure this out here. Oh yeah, another reason 6 is a cool number is that you only get 6 partials. This is partial 1, which is 1. This is partial 2, which is 2, 3, 4, 5, and 6. Ratios in music. 2 over 1 is an octave, C to C. 3 over 2 is a fifth, G to C. 4 over 3 is a fourth, C to G. No, I did that wrong. C, E, G. Okay, this is E, okay? Yeah, there we go. Now I did it right. So 2 to 1 is C to C, octave. 3 over 2 is G to C, or G to C, which is C to G is a fifth. 4 to 3 is C over G, which is G to C, G, which is the perfect fourth. 5 to 4 is E over C, which is E, C to E, major third. 6 over 5 is G over E, and E to G is a minor third. So octave, fifth, fourth, major third, minor third. If you go to 7, you get this out of tune monster. 7 is not good. It's like between A and B flat. It doesn't fit our system. It's awkward. It's outside of our tuning system. You don't get to have a note that suddenly manifests between 2 chromatic notes and call that a note. So 7 is actually the first prime number that gets ousted as an interval in Western music. The first prime number 2 is an octave. 3, next prime number is a G, which is the fifth. Third prime number is E. 5, which is E, which is the major third. And then the minor third is the difference between the major third and a fifth. And the perfect fourth is the difference between perfect fifth and an octave. But 7 doesn't help us. 7 is just out to lunch. So it makes me think two things. So 7 is not that great of a number after all. Because you don't need 7 as 7 doesn't help us note wise, and also it emphasizes once again that 6 is a cool number. You can go partials up to 6 are good. The 7th one gets cast out, so 6 is actually beats 7 in that scenario. Not only that, the Bible says we're supposed to rest on the 7th day, which means do nothing, because we don't like that day. We're supposed to not do anything. We're supposed to lay around. Well, God rested because that was a weird number day. I don't know. I don't know. I don't know what I'm talking about really. I'm just throwing thoughts out there. But you're supposed to rest on the 7th day, as if that's not the real. The number of weeks is really. Think about this. We don't have a 7-day week because of the 7th day. We have a 7-day week because of what happened on the first days, which was creation. 6 days, and then the 7th was just added for rest. All the creation was actually done in 6 days. 6 is the real mover in that equation, I think. And that's if the Bible's true, but whatever. Now, one more thing. Pentagrams. Let's start with an upside down one. Let's go like this. Let's go. Oh yeah, good job, Jimmie. Do this again here. Geez, it's hard to draw a pentagram. That's right side up though. How do I do it upside down? That's still right side up. Am I not good at this? There we have it. It's an upside down pentagram. Let's do a smaller one. Let's do a little guy. And I dropped my pen. Why not? Why not let that happen? Yeah. Oh, that's supposed to be an upside down one. It doesn't even look like a pentagram. Almost had it. Almost had it. Try once again. Dude, it's just a simple drawing. Yeah, there we go, sucker. Got it. Haha. Who's the dude now? Do a circle outside that, and then actually this should touch the circle. That's not accurate. There you go. And then you have this. You have a trapezoid that goes like this. It's not a parallelogram. It's not a rectangle. It's not a square. It's a trapezoid. This thing right here, which again informs. That's not true. That was that. This trapezoid informs this. That I think. I suck at drawing, don't I? Oh, okay. Try it again. I am not an artist drawing wise. What's this doing down here? Jesus. You have the right side up one this time. So it would be. Oh, I get it. Do I? It's trapezoid, right? Something like that. You get right side up pentagram. If you go outside of this to this one, you get a right side up pentagram outside of it. I can't draw for nothing, huh? Then that gives you another pentagram outside of it. The first one is upside down and gives you the trapezoid that then implies the second one, which is right side up. And then that can be a right. So it alternates as you go further and further, right upside down, right side up, and so forth. What's interesting about this, at least one thing that is that if you look at the, drop the stupid, I'm going to throw this over the fence. Okay, so look at this, the little upside down one inside, and you have this this little distance right here. It's the simplest distance of all in all of them. This little distance over this distance right here times the Golden ratio is this distance, because this to this is this to this. This to this to this is this to the whole thing. So this is phi. This times phi. So this is, let's call it x. This is phi times x right here. This is phi times x. But look at this. This to this whole thing is the whole thing to this. I think. Wait, let me get this right. Oh yeah, this to this is this. Okay, this to this is the whole thing here to this. So that's from here to this is two is phi squared, because you go from here, from the little guy from the littlest guy to here is 1 phi, but from here to this whole thing is phi squared, 2 phi. What did you do next? Well, this guy to wait, am I doing this right? Let's see, this little guy here, and the phi. Oh, did I not do it enough? It would help if I could draw. This little phi, this littlest phi to this is 1 phi. This is, oh yeah, this to this is a phi. This to this is a phi. Somewhere I'm not doing this right. And then this. Oh, let me start over. Dude, I can't draw. Little one inside. Upside down. Wish. Okay, that's an upside down pentagram. Pentagram. This to this is phi. This to this is phi. So this is phi. But this to this whole thing is phi cubed. Then if I make my right side up one, this is phi cubed right here. That means that this that this to this down here is phi to the fourth power, because if you make this can go out to here, then by this much, and this comes down to here by, this goes a little bit more, this goes up further and cuts in like this, and you see that this and this is this and this, so this to this is this to this whole thing. And this whole thing right here is to this outside pentagram, which would be this here. This little guy in here. Oh yeah, the little guy. This here would be this here right here is for the, because I made a pentagram, didn't I? Started with this inner one. Yeah, like this. This inner one here. Yeah, the outer pentagram. Trying to show phi to the fourth relationship. So under here, that's right side up though. Okay, better. All right, and the right side, this one goes like this. And then, yeah, right side up. Down, there we go. And then you're gonna make a bigger one on this guy. Okay, that guy right there, this guy. Oh yeah, see it right here. The pentagram. Point down here. And then, like that. There we go. Okay, so this little guy to here is phi, from here to here is phi, from here to here is phi. That's 3 phis. So I want to get the final one, which is this guy, I think. Yeah, because this guy, make the outer one like that. Let's see. The line here was the littlest guy. So in this whole big one, our littlest guy is, so this is a right side up. Pentagram. Oh yeah, our littlest guy is right here. Yeah, that's right, which is this. Yeah, the littlest guy for this one is this guy, right here to here. Let's start over now. The littlest guy is the upside down one. From here to here is 1, from here to here is 2, from here to here is 3, and then this guy is 4. This is 4 times phi. The first phi, yeah, 4 phi from this littlest guy in here is 4, I think. Oh, we want this whole thing. That's what we're after. This is what we're after. And starting from this little guy here to this whole big guy. Oh, I get it. So from here to here is phi, from here to here is phi, from here to here is phi, and from here to here is phi, because we have this. And this here to here is this here to there, but this here to here is this here to a bigger one. Here, here to here is here to an even bigger one. So this is 4 phi times the littlest one in the middle. So you have to multiply by, to get this little guy to this big guy, you have to multiply by phi 4 times. Once to go from here to here, once to go from here to here, once to go from here to here, and once to go from here. Wait, let me do that again. From here to here is phi, from here to here is phi, from here to here is phi, from here to here is phi. I didn't do that right. Okay, here to here is phi, here to here is phi, here to here is phi. Yes, no. Dude, what am I doing wrong? Okay, 1 phi, 1 to phi squared, 1 to phi. Oh yeah, I had it right. Here to here is 1 phi. Here to here is 2 phi. Here to here is 3 phi. Here to here 1. Okay, now go to here, 2, 3, 1, 1, 2. Yes, I'm getting it. So this is x. This is phi times x. 2 phi times x squared. 2 phi. 2 phi x. Yeah. 1 phi. 2 phis. 3 phis. And because of this to this is 4 phis. Yes, I got it. Because this is a little guy, big guy. Yeah, like this. And so from here to here, divided by phi would be here to here. Divided by another phi would be here to here. Divided by another phi would be here to here. Divided by the smallest phi is here to here. So to get this distance to this distance, you multiply by phi 4 times, which is phi to the 4th power. So x times phi to the 4th is y. If this is y, this whole length here is y. If this littlest guy is x, then y, then y equals x phi to the 4th power. So yes, y equals phi to the 1 power is from here to here, to the 3rd power from here to here, to the 4th power from here to here. Okay, first power, 0 power is 1, phi to the 1, phi to the 2, phi to the 3, which is also this, and phi to the 4 is the whole thing. That's right. I did it. I know I did it. Because this you have to go, yeah, multiply. Here's 1, 2, and then 3, which is the whole thing from here to here. Oh, okay. Here to here is phi. Here to here is phi squared. Here to here is phi cubed. Here to here is phi to the 4th. That's what I'm doing wrong. So x times phi, x times phi, x times phi to the 1st, x times phi to the 3rd, and x times phi to the 4th. Yeah, I did it. 1, 2, 3. Yep. So this y is x phi to the 4th. Take this number x, multiply by phi times phi times phi times phi, and you get this one. That's intricate relationships in pentagrams. Plus this one's upside down, this one's right side up. Yeah, so 1, 2, 3, 4. Yep. I think that's interesting. So I love you guys. Peace, love, and rock and roll.